In today's video, we're going to be walking through a few problems solving derivatives for 100 level university, which is also similar to the work that you do in A-level mathematics. So the very first question is find the average rate of change of f of x equals to the square root of 3x plus 1. So I'll just write it out. On the interval 5 to 8. Okay, so we need to find the average rate of change. Now, the very first thing to understand in derivatives, so this is differentiation. We're simply finding the slope of a line or the slope of a curve at a certain point. So here, where they're asking us to find the average rate of change, all we're going to do is the change in y divided by the change in x. So this interval here is in x coordinates. So our 5 is x1 and 8 is x2. So what we're going to do here then is it's simply just going to be y2 minus y1 over x2 minus x1. That is the formula for finding the average rate of change. So y here, right, that represents f of x. So this here is x2. So what I'm going to go ahead and do is substitute that value in to this function here in order to get y2. So y2, we're going to solve for y2 here. So we get y2 when we substitute x2 into f of x. So the square root of 3 times 8 plus 1. That's going to equal to the square root of 3 times 8 is 24 plus 1 is 25 is equal to plus or minus 5. Okay? And here we're just going to be taking the positive value. In this situation, we're taking the positive value. Now, what is next is then to do the same thing for our x1 value. So to find our y1, we need to substitute x1 into f of x. So the square root of 3 times 5 plus 1. 3 times 5, 15, plus 1, 16. So it's going to be the square root of 16. And once again, that's plus or minus 4. And we're going to take the positive value there. So our coordinates are now going to be 5, 4, and 8, 5. So x1, y1, and then x2, y2. Okay, those are going to be our two coordinates here. So what we then do is we take these coordinates and we substitute them into this formula here to find the average rate of change for this function in this interval. Okay, so y2 minus y1. So it's going to be 5 minus 4 over x2 minus x1. x2 is 8 minus x1, which is 5. That's going to give us 1 over 3. So that's going to be our average rate of change. So if I go ahead and I type that in, okay, and that's correct. Okay, 1 over 3 is our average rate of change. Now, they've given us a second question. Find the average rate of change of f of x is equal to the square root of 3x plus 1 for the interval 16, 21. So it's the exact same thing now with different numbers. So what I'm going to go ahead and do, so to get y1, I have to substitute x1. Okay, so 3 times 16, I'm just going to do this in my mind. 3 times 16 is 48, plus 1 is 49. So y1 is therefore going to be equal to 7. For y2, we substitute x2 in. So 3 times 21 is 63, plus 1 is 64. So the square root of 64, that's just going to be 8. Okay, so now we plug it into this formula to find the average rate of change. So y2, which is 8, minus y1, which is 7, over x2, which is 21 here, minus x1, which is 16. That's going to give us 1 over 5. So that's going to be our rate of change. So let's go ahead and substitute that in. Write that answer, and sorry, not substitute that in. Okay, 1 over 5, and we'll check that. Awesome, and that's correct. Okay, now we're on to question 3. Right, so we did more working here, and now it's just going to be a little bit quicker because we're sort of repeating the same things. Again, function f of x for the interval 3x plus 1, function f of x equal to the square root of 3x plus 1 in the interval of 16 to 16 plus h. Okay, so now we have this constant here. So it's the same thing, but now we're not going to get a answer that's a whole number. It's going to have a variable in it, right? The average rate of change is not going to be constant. It's going to have this value here. So again, substituting these values in. So y1 is simply going to be, we substitute 16, we're going to get the exact same thing there, 7. y2, however, is going to be equal to the square root of 3 times x. 2 is 3 times x2, so 16 plus 8 plus h, sorry, bracket plus 1. That's going to be equal to the square root of 48 plus 3h plus 1 is equal to the square root of 49, right? We can add the like terms, plus 3h. Then we're going to go ahead and substitute that into our formula to find the average rate of change. So it's going to be y2, which is this here. So it's going to be equal to the square root of 49 plus 3h minus y1, which is 7, over x2 minus x1. So our x2 is the 16 plus h, and our x1 is 16 here. 16 and 16 are like terms. So then that takes us down to the square root of 49 plus 3h minus 7 over h. Okay. And then we'll just type that in. Okay, and then that is correct as well. All right, so now we're going to go to the next questions. Okay, so it's telling us that a person took a trip to visit their sibling, and at the start of the trip, the odometer read 21,395. 6 hours later, at the end of the trip, the odometer read 21,907. Okay, so after 6 hours, 6 hours later. So assuming the scale of the odometer on the car is in kilometers, what is the average speed the car traveled during the trip? So give your answer to 1 decimal place. Okay. So what I'm just going to do then is you just calculate the difference, divide it by the number of hours, and that's going to give us the average distance covered per hour. Okay, which is going to be our kilometers per hour, which is the speed. So very simply then, 21,907 minus 21,395 is going to be 512, divided by 6 hours is going to be 85.3 reoccurring kilometers per hour. So I'm actually just going to go ahead and answer that. So 85, and it says give your answer to 1 decimal place, don't include any units. So I'm just going to leave it as 85.3, and let's check if that's correct. Okay, so that's good, right? So all this question was, we have odometer at the start, odometer at the end after 6 hours, and we wanted to find what was the average speed during that journey, and we just found the difference divided by the number of hours, and that gives us 85.3 kilometers per hour. Okay, next question. Okay, so our next question is then asking us to find the derivative of the following function. So it is y is equal to 4x to the negative 5 minus 2x to the power of 3 plus 3 over the square root of x plus 5 pi. Okay, so find the derivative of the following function. All right, so again, we're wanting to repeat. When we find the derivative, we're differentiating, and we're literally just finding what the slope of the respective function is at a certain point. Okay, so here we have this function. Now, when we differentiate, what we do is we take the power, we multiply it by the coefficient, and then we add 1? And then we subtract 1 from that power. All right, so here it's going to be negative 5 times 4 is negative 20 times x to the power of negative 5 minus 1, negative 6. Now here we have, this here is basically the same as writing, actually I'll just do it here, 2x to the power of negative 3 plus 3 to the power of times x to the power of negative a half, right? Because x to the power of a half is equal to the square root of x. And then if we add that negative sign, then that goes down to the denominator. And then we have plus 5 pi. So I'm actually doing a few extra steps here. So we're going to have negative 20x to the minus 6. Now, negative 3 times negative 2, that's going to be positive 6. So plus 6 times x, negative 3 times minus 1, negative 4. Okay, now we're over here. 3 times negative 1/2 is going to be negative 3 over 2 times x to the power of, what's negative 1/2 minus 1? It's going to be negative 1.5. So negative 3 over 2. And here, if we have constants, right, this is a whole number. When we differentiate, they simply differentiate to 0. So that is just going to cancel out. So this here is going to be our differentiated answer, our differentiated answer to this function. So if I go ahead and write that, it's going to be negative 20x to the power of, now if we actually, we'll just leave it like that. But at the same time, we could then also make this here 6 over x to the 4, or negative 20 over x to the 6, or negative 3 over 2 times the square root of x cubed. I believe that is the answer, right? If we have 9 to the power of 3 over 2, it's 27, because it is the same as the square root of 9 to the power of 3. Exactly. Okay, so this bottom value here is the square, right? If it's a value, a to the power of 1 over 3, then it's going to be the cube root of a, right? And I'll show that here. So if I have, let's say, 8 to the power of a third, that's going to be 2. It's the same as the cube root of 8. Okay, so I was just explaining that so that you can understand that this answer can be written in a couple of different ways. But for now, I'm just going to leave it like that. So to the power of negative 6 plus 6x to the power of negative 4 minus 3 over 2, oops, minus 3 over 2 x to the power of negative 3 over 2. Okay, now let's, oh, that was not a fraction there, minus 3 over 2. Okay, now that's my answer. Okay, now let's see if that is correct. Awesome, that's correct. Okay, now we'll go to the next question. So it is saying, find the derivative of the following function. So once again, another question solving derivatives. So y is equal to bracket 6x 4 minus 4x plus 3 times x minus 2. Okay, so here we have a function that has two different, I guess, components that are being multiplied by one another. And in this scenario, what we can do, well, this isn't a composite function. We're going to be using the chain rule. Now, the way that the chain rule works, okay, so this here is going to be using the product rule. So basically what we can see is we have two different functions that are being multiplied by one another. And the product rule states that when we have something like that, the first derivative is going to be equal to the first derivative of f of x times g of x plus f of x times the first derivative of g of x. Okay, so then the first derivative of y here, I'll write what I just said down, times g of x plus f of x times the first derivative of g of x. So here, f of x is going to be equal to 6x to the power of 4 minus 4x plus 3. And then g of x is going to be equal to x minus 2. Now the first derivative of f of x is simply, we're just going to derive that. So we're going to differentiate this. So it's going to be 6 times 4, so 24. Take 1 off the power, so right, we're differentiating. So now it's going to be to the power of 3 minus, here, imagine there's a 1. So now it's going to be minus 1 times 4 is 4. Take that off, right? So you take 1 power off, and then it's going to be to the power of 0, right? And anything to the power of 0 is simply 1. So then it's just going to be 4. And then here, right, a constant, when it's differentiated, just becomes 0. So this here is going to be the first derivative of f of x. Now if we do the same thing to g of x, that's just going to leave us with 1. Okay? So now we have to go ahead and do this here. So it's going to be the first derivative of f of x times g of x plus f of x times the first derivative of g of x. So I'm going to go ahead and do that. So it's going to be equal to, so then this here, we're going to write that formula. So the first derivative of y is going to be equal to 24x cubed minus 4 multiplied by x minus 2 plus f of x times the first derivative of g of x, which is just 1, so it's just going to be plus 6x to the power of 4 minus 4x plus 3. Now, we can expand these out, and we actually will do that, because then it's going to make everything easier, I think, to... Actually, no, let's just see, we can write this answer as is. So it's going to be our answer, but what we could do is expand out these brackets, and then we'd get 24x to the power of 4, which could then be combined with 6x to the power of 4. Okay, I think we'll probably actually just do that then. So 24x cubed times x is simply going to be 24x to the 4. 24x cubed times negative 2 is going to be negative 48x to the power of 3. Negative 4 times x is going to be minus 4x. Negative 4 times negative 2 is going to be positive 8. Plus 6x to the 4 minus 4x plus 3. Now we have to combine the like terms. So x to the 4, x to the 4. So these can be added. So 24 plus 6, that's going to be 30x to the 4. We don't have any other value, any other x to the cube, so it's just going to remain 48x to the power of 3. Negative 4x minus 4x is going to be negative 8x. 8 plus 3 is going to be 11. All right, and so that is going to be our answer. So let's see if that's correct. So 30x to the power of 4 minus 48x to the power of 3 minus 8x plus 11. Okay, now let's see if that's correct. Awesome, that is correct. Okay, now we're on to the next question. So again, finding the derivative. So it's going to be 2x to the 4 minus 9 over x to the 5 minus 6x squared plus 10. Now we're going to use the quotient rule. Now we need to know that the quotient rule is very simply, so this here is our function, and it is in the form of f of x over g of x. Now that's why. When we differentiate this, what then happens is we get the first derivative of f of x times g of x, like we had here, but now it's minus f of x times the first derivative of g of x all over the square root of g of x squared. So all over g of x squared, not the square root. That's my mistake. All right, so then again, what we're going to go ahead and do is find the first derivative of f of x, which is our numerator here. So f of x is equal to 2x to the power of 4 minus 9. So the first derivative is going to be 2 times 4, so 8x, knock that down 1, and then this here just becomes 0. So that's going to be the first derivative of f of x. Now g of x, okay, I'm just going to do that like that. We can see it's a little bit more complex. So it's x to the 5 minus 6x squared plus 10. So the first derivative of g of x is going to be 5 comes down here. So 5 times 1. This is an imaginary 1 as the coefficient of x to the 5. 5x. Take away 1 value from our power here. So 5 minus 1 is 4. Then we do 6 times 2 is 12. 2 minus 1, right? We knock that once down. That's just going to be x, so minus 12x. And then because we just have a constant here, when we differentiate, again, it becomes 0. So now we have all of the components of this formula here. And what we need to then do is go ahead and just plug them in. So f of the first derivative of f of x times g of x. So it's going to be 8x cubed. Right, so then we're coming down here. So the first derivative of y is going to be equal to 8x cubed times g of x. So x to the 5 minus 6x squared plus 10 minus f of x, 2x4 minus 9, times the first derivative of g of x. 5x4 minus 12x. And this is all going to be over g of x squared. So our value here, x5 minus 6x to the power of 2 plus 10, all of that squared. So now what we're going to do is we can actually probably just leave it right now as it is. I think if we expand this out, then it's going to become even more difficult to deal with. So I'm actually just going to go ahead and submit this answer as it is. So 8x over 3, or 8x to the power of 3, times x to the power of 5, x to the power of 5, minus 6x to the power of 2, plus 10, minus 2x to the power of 4, minus 9, times 5x to the power of 4, minus 12x, over x to the power of 5, minus 6x squared, plus 10, all to the power of 2. Okay, let's see if it accepts this as our answer. Okay, and that's correct as well. Right, so we use the quotient rule, and we found the first derivative of that problem. Okay. Now we're moving on to a new problem. So it says for the next 3 questions, we're going to be working with the function y is equal to 2x cubed minus x squared plus 3x plus 1. Now it's important to note I am going quite slowly here because I'm actually working through these questions for the first time. So as I'm doing these problems, you should also try doing them yourself as well, and then we can compare the answers and see if what your answer is correct. Right, so right now they're asking us to, for part A, find the first derivative of y. So we're just going to differentiate this. So 2 times 3 is just going to be 6. We take the 3 down, we minus 1, this is going to be 2. 1 times 2 is going to be 2. Take away 1 from 2 is just going to be 1, so it's minus 2x. Then we just have plus 3, right? Because if we take, this is to the power of 1, take 1 away, then it's going to be 0. So then it just becomes 3 times 1. Bring that down to 0. X to the power of 0 is just 1. So that is our first derivative. Then it's asking us to find the second derivative. So to find the second derivative, then we just differentiate the first derivative. So 6 times 2 is 12, and that's going to be times x, right? 2 minus 1 is 1, so 12x. This is the same as x to the power of 1. minus 2. Okay, and from now on, I'm probably not going to explain anymore how we actually differentiate. We're just going to go ahead and solve these problems. So those are going to be my answers. So let's go ahead and see if these are correct. So 6x to the power of 2 minus 2x plus 3. That's going to be my first answer for the first derivative of y. And then the second derivative of is just going to be 12x minus 2. So let's check those. Awesome, and both of those are correct. Now it's asking us to find the rate of change of y with respect to x at x is equal to 2. So finding the rate of change of y with respect to x, that's just going to be the first derivative. So it's important to understand what the first derivative and what the second derivative show. So let's say we're looking at a graph and it's about the speed of or the distance traveled of a vehicle. The first derivative will help us identify the speed of that vehicle, and the second derivative will then help us identify the acceleration of that vehicle at a certain point in time. So here, right, we're using the same problem, the same function, and it's asking us to find the rate of change of y with respect to x at x is equal to 2. Okay, so then we're just going to go ahead and sub x is equal to 2 in that. So 6 times 2 squared minus 2 times 2 plus 3 is going to be 23. So let's see if that is correct. The rate of change of y with respect to x. Awesome, and that's correct as well. Okay. Now we're on to one of the final questions. All right, so it's asking us, what is the slope of the tangent to the curve when x is equal to 1? All right, so this here, we're now getting into a really nice question. All right, so y is equal to 2x cubed minus x squared plus 3x plus 1. And part A is asking us to find the slope of tangent to the curve when x is equal to negative 1. All right. Okay, so I'm quickly going to actually do a little bit of a graph so that you can kind of identify what we're actually doing here. So we can see that the highest power is 3, so it's going to be a cubic. So it's probably going to be something like this. I'm not sure exactly, but it will have this sort of shape. Now, for the purpose of this question, it's asking us, right, when x is equal to 1, we need to find the slope of the tangent to the curve. So what is a tangent? A tangent is simply a straight line that touches a curve at one point. Okay, so if we have this curve here, the tangent touches 1 point. If there is a line that touches 2 points of the line or the curve, then it's a secant. Okay, so here we have tangent, so it's touching the line at 1 point. Now the question is asking us to find the slope of the tangent. So slope is simply how much do we have to go up and across of, or the slope is the gradient, right? How much do we go up and across on the respective line? So here, for example, you can see that the gradient might be, let's say, 1, right? For every 1 unit that we go across on the x-axis, right? So x is this way, right? It's horizontally, y to the sky. So for each unit that we go across on the x-axis, we go up 1 on the y-axis, right? So that would be if our gradient was 1. So what this question is asking us is to find the slope, the gradient of the tangent to the curve when x is equal to 1. So it sounds complex, but in reality, it is actually quite simple. Now, the very first thing that I'm going to do is I'm going to look to find the y-coordinate of this point here. So when x is equal to 1, what is y equal to? And to do that, all I have to do is substitute -1 into this function here. And that's going to give me y is equal to 2 times -1 cubed minus x times -1 squared plus 3 times -1 plus 1. So y is equal to -5. So our point is going to be -1, -5. This is going to be the point at which our tangent touches the curve. All right? So that's important because we know that all straight lines are in the form of y is equal to mx plus c. Okay, and we've already got our y coordinate, we've already got an x coordinate. Now we need to just find the gradient at that respective point, and then we can find c, and then we can have our formula, our equation for that tangent. So you might have caught on right there. I said we need to find the gradient at that respective point on the curve. And how do we find the gradient? Well, we find the first derivative of a function. So I'm simply going to find the first derivative of our function here. So the first derivative will be 2 times 3, so 6x squared minus 2x plus 3. That's going to be our first derivative, which is our gradient. Okay, the first derivative shows us the rate of change at a certain point. And I'm going to substitute in our x is equal to -1 point in order to get that value. All right, so then it's basically going to be m, which is our gradient at that certain point, is going to be 6 times -1 squared minus 2 times -1 plus 3. So it's going to be 11. So now we already have the core pieces of information that we need to plug into this formula here to actually find the equation of the tangent and therefore find the slope. Or actually, no, right now we're already going ahead and we're doing part B, which is to find the equation of the tangent. Part A is to simply find the slope, and we've done that right here. So our gradient, our slope, is equal to 11. Now, part B is to find the equation. Find the equation. So what I was working on there, y is equal to 11x plus c. But how are we going to find that c? Well, we already have this coordinate through which we know our tangent passes through, so we can plug that in and then find our c value. So if we make here y -5 is equal to 11 times -1 plus c, we know that this equation must be true, right? Because our tangent passes through our curve, and therefore it shares that same point. And so when x equals -1 on this curve, whatever, so when x is equal to -1 on this curve, the y value will be the same as on the line. All right, so then when we go ahead and we plug those coordinates into our line equation here, the equation of the tangent, it must be true. And so we can find c. So -5 is equal to -11 plus c. Add 11 to both sides, and we get 6. C is equal to 6. Okay, and so therefore, y is equal to 11x plus 6. So 11x plus 6. Let's go ahead and see if that's actually correct. Awesome, and that's correct. All right. If you're not sure of how I worked through that, put a comment down in the comment section below, and let's start a little bit of a discussion. I'm more than happy to try and help and try and explain these different concepts. All right, so that's actually our last question of this quiz. If you have any questions, as I just mentioned, put them down in the comment section below. Put any of the other topics as well that you want me to explain in the comments below, and I'll try my best to make some videos on those different topics. I hope you enjoyed the video. I hope you have a good day, and thank you very much for watching. Bye.